Hey guys, what's going on? So, we have talked about acid, the four properties, in a theoretical manner, but it's time to put them in practice and explain those four properties in an actual database setting. So, I'm going to pick Postgres, but you can do the same exercise with any database you want. For simplicity, I'd like to use Docker because this way I can try out many databases with just one command, and I have spin up another database just like that. So let's go ahead and spin up a database right here. You know what, I'm going to keep this up because I'm going to need the two terminals, but I'm going to spin up a new one right here. And let's spin up a Postgres container. I'm going to do Docker run. Let's call it Docker run. Let's give it a name, dash name. It's going to call it acid. Let's go PG acid. Then we're gonna do, we don't really need to expose the port or anything because we're gonna really go into the container itself, bash into the container. The next command is, let's go ahead and detach that. And then let's pull up Postgres 13. I think that's the latest thing, right? And before we run that, actually, we forgot something very important, which is -e Postgres password equal Postgres. You have to give a Postgres user a password. Let's go ahead and run that. Just like that. It's going to take a little bit while on your end to load the Postgres image, but once you have it, you're ready to rock and roll. Let's go ahead and let's make sure that the container is running. And just like that, yes, here's my PG acid. It's running. May always make sure that it's running because you might have spilled something in the command or did something. If it's not running, something is wrong, right? So let's go ahead and do docker exec -it and then get into the PG acid. And what command do we want to execute? psql, because that's the PostgreSQL command. And I want to log in as -u, the Postgres user. And that just like that, we are in the Postgres command shell. Now we can execute beautiful stuff. We can create a database, we can play with that, create tables. So since I'm in the Postgres database, I have a database called Postgres. So I'm going to play up with that database right there, right? So let's go ahead and do create a table called products to test atomicity, right? I'm going to go ahead and create table products. Let's do a PID serial. So that's an auto increment in MySQL, I think it's called. And sure, let's make this the primary key. And I think we can just continue doing that stuff, right? In a new line. And name as a text. Boom. What else? Price is double. I'm not sure it's double or float in Postgres. I keep forgetting in different databases. When you work with many databases, you get confused. And the finally is inventory. How much inventory do we have in this product? And then let's just use an integer here. And that should be it. Yeah, that's what I thought. It's not called double. It's gotta be float, I think. There you go. I think it's double in MySQL or Oracle. I keep forgetting. All right, now we have a product table. Let's go ahead and create a sales table so we can produce sales. Create table sales. Let's go ahead and do a sale ID. That's a serial. Also primary key. Let's hit enter. The primary key, that's the product ID. I can create it as a foreign key, but it doesn't have to. So that's an integer. All right, that's a product ID, an integer. Boom, price float. We learned our lesson. So that's an entry in the sales. What could be a product could be sold in a different price, right? But the current price of the product is in the product table. This is what was sold at, right? And then the quantity as also an integer. And boom. All right, now we have these two beautiful tables. Let's test out atomicity. So for the first thing, let's populate some rows on those tables, right? So I was going to do insert into products, and let's give it a name. I don't know. What are we inserting? Name and a price and inventory For simplicity, I'm just gonna do one row here. Let's call this a table. I don't, table's very confusing. Phone. I don't know. You're selling phones, and the price of the phone is $999.999. That's an expensive phone. Inventory. Let's say you have 100 units, and then boom, and then that's it. That's the only product we have. Okay. So now let's test out our atomicity. So, I mean, if we did select star from products, you can see that we have this row, right? What we're going to do is we're going to make a sale. We're going to sell, let's say, 10 phones. Like we sold 10 phones. What does that mean, right? If you're working with domain-driven design, that is one task, right? But it's in the database, it's broken into multiple queries in a single transaction, right? So a sale is of 10 units. That means you have to deduct 10 units from the inventory, and then you have to insert a row in the sales table saying that you have inserted that. You cannot do that in two transactions. You have to do it in an atomic transaction. That's what we explained in the video, right? In the lecture. So let's go ahead and begin a transaction. And then we're gonna, the first transaction we're gonna do is update products. All right. What was the phone ID again? Let's just do from products. You might want a query, so process ID number 1, process product ID number 1. So what we're gonna do is update products, set name, update products, set inventory equal inventory minus 10, right? Boom, that's in this transaction. So now if I query that product again, you can see it's 90, right? Very, very critical here. So now if I go ahead and insert, let's assume I crashed right here. If I crashed right here, what will happen? You just lost 10 units from your phones that you didn't really sold, okay? And that's the idea of atomicity, because you have to follow it up, right? So like, let's say I crashed right here, like, I don't know, just killed the whole container, right? Just like that, right? If you do that without atomicity, it will be a disaster. If you come back to the database and then you said select star from product and you saw that it's a 90, but no, it says it's 100. Why? Because of atomicity. We started a transaction, we did an update, but we crashed. We exited Postgres in this case, simulating a crash, right? That is the idea of atomicity. All the transactions have to be done in as an atom, right? You cannot split those. Okay? Let's do the transaction again in the right way by doing begin transaction, doing an update to the inventory, and then now I'm going to insert a sale. Insert into sales, process ID, price, and quantity, right? Let's just do boom values. Number 1, I sold it at, I don't know, I sold it at 999.99, same price. And I sold 10 units, right? And you can break it out into 5 units at this price and 5 units at this price. Who knows, right? And as we did that, now if I do query the sales tables, you can see that we have 10 beautiful units right here, and my products are 90. So now if you sum those puppies up, you get 100, and that's called consistency. We just explained atomicity and consistency in the same concept, right? And this is only viewable in my transaction. So now if I went to a completely different terminal and try to query, again, I'm not committing yet, right? And I do it like, I don't know, let's do the same thing. Hopefully we have, so let's go there, PG acid. And then if I do select star from products, you can say that's still 100. And if you query the sales table, there is nothing. And that's part of isolation, right? Because now we're in an atomic manner. So these two things were inserted in that transaction, but we didn't roll back or commit, right? The moment I commit, now we have a nice view and of the data, and the data is now flushed and available, visible to all transactions. Now, if I query it again, you can see that we have a sales now. It's not 0, so there's a 1. And if you query the products table, you can see there's 90. So what we're talking about here, talking about atomicity, we talked about consistency, because if you don't have atomicity, you don't have consistency. And you can argue with that, obviously, guys, because you can say, hey, no, I can be smart and make a single query, right? And then for the longest time, MongoDB, for example, didn't have atomicity across documents. It has only atomicity across a single document. And people were fine with that, because most of the time they will do their data model so that it is a single document instead of let's say normalized like we do here. All right, let's jump into isolation. All right, guys, so I went ahead and inserted a few rows in the table. You don't have to see the process. I'm going to cut it out. It's a straightforward thing. We sold a couple of units right here, a couple of units right here. So now let's test out isolation. And to test out isolation, guys, I want to do the following, right? So to test out isolation, guys, I want to do the following, right? Just with normal transactions. I'm going to start a transaction in my first session right here. And I'm going to do a normal query saying select product and the count of the product. All right. I just want to see how much sales did I made or for each product, right? From sales and group by PID. Boom. If I do that, all of a sudden now in this query, I have 3 sales for product 2 and 3 sales for product 1, which is pretty good, all right? Now I want to actually print the report that shows that what are this list, just the whole thing. So in order to do that, you do select product, price, maybe you do a join, but we're not gonna do that. Quantity from sales. That's it, right? But before you're going to execute that, another session started right here, okay, and inserted a new sale, okay? You just inserted a new sale, right? And you are just doing your own thing right here in generating this large report, right? But you reach this stage, and meanwhile, think of these two as concurrent application transaction going at the same time. Someone is making a sale, someone is generating a report. So in the same time, I'm going to generate a new sale. Hey, we just sold a new phone, right? PID, and let's say price and quantity, right? Values. We sold a new phone, right? And price 999, the 99, yeah, let's just say we sold 10 more phones, and we also go ahead and update the products where set set inventory equal inventory minus 10, where PID equal 1, because we just made a sale, right? So we need to decrement that. And then what we did is like we actually committed. We're done. We made a sale. And if we went back here, we're continuing to generate the report. Again, this is happening in parallel, right? I'm pausing it just to show you. But this is, now we made a sale, and then you printed the record, right? So you printed that you made three sales here, and then you actually printed that stuff. And guess what, guys? This don't match. You said that and this happens a lot, right? In actual companies where the actual table doesn't match the counts. And this happens if you do this kind of things. This I'm going to talk about. This is called isolation. The concept of isolation. We're not fully isolated here. So what happened here is we printed this puppy, right? And we said, okay, we made 3 phones, actually 4 phones, and 2 and 3 earbuds. So the earbuds are correct, but the phones are not correct. You just produced an inconsistent view. So inconsistency or consistency in general can happen because of atomicity, which we explained, and can also happen because of isolation, which is what I'm about to explain here. So how do I make sure that nobody touches my view when I am beginning my transaction? If I am starting this transaction, I want you to give me a snapshot, right, of all the queries that I'm going to do as if at the moment of where the transaction started. And that's called repeatable read. So let's go ahead and roll back this thing, right? And then we'll do a begin transaction, but we're going to do isolation level repeatable read. I think that's how you say it. The default was read committed. What that means, anything that has been committed on other transaction, I can see it. And this isolation level works most of the time, but sometimes in this case, you don't want it. You don't want a repeatable read or serializable. So let's go ahead and start in a repeatable read. And now, if I'm going to make my beautiful query, the count, hey, there are 3 and 4, which is good. So we made 4 sales. But look at that. I'm about to execute the second query to query the sale. But in the meantime, someone started another transaction. We don't care which isolation level at that point, but they inserted another sale, same sale exactly, and they committed. So they just made another sale. But if you query this, notice that it didn't show up on your case here. Why? Because your isolation level prevents you from seeing stuff that other people is changing. That's a beautiful repeatable read. It's expensive. You gotta understand how it works, right? Because it works at the MVCC level, and Postgres does it differently. MySQL does it differently. SQL Server does it differently. Oracle does it exactly very similar to MySQL. Actually, MySQL does it very similar to Oracle, if you want to be very precise. But that's it. Now, if you have a consistent view, you made 5 sales technically on the iPhone. But if you query again that group by, you only see 4. Go ahead in this other query, right? If another session, if you do select PID count PID from what is that? So we have 5 units here, but here, no matter how many times you execute that, you're going to get a repeatable read. Your read is repeatable. It's not going to change. And that's a very attractive feature for a lot of applications, right? So now once you commit or roll back, you're done. If you execute that query again, you see 5 because you're out of your transaction. All right, guys, that was isolation. Finally, for the fun of it, let's do this. There's exit right here, and then Docker. I'm going to do this. I'm going to begin a transaction, and then I'm going to insert a new product. To explain durability. Insert a new product, and I'm going to prepare here to kill the container, the whole container, PG stop, right? But in the exact same second, I am going to insert a new sales and see if this is actually going to happen. If I say, if it says commit, what will happen here? Name, price, inventory. Yeah, let's just insert a new product. That's called TV. Yeah, $3,000. And there is only 10 units of this. And I'm going to do this, and I'm going to commit but at the same time, I'm going to kill the container. See, immediately we were killed. So now I want to know, did my TV get recorded? The Postgres did told us that it's committed, right? If I do this, and a lot of database doesn't support this, by the way, like Redis. Redis is an in-memory database, but it does support persistence, right? But essentially, a durability is, it means if you tell me that you committed something, that means if I log in again, it better be there. So let's see if is it there. Yep, it's right there. Because it told me it committed, if it didn't return the commit, that means it hasn't been written, right? And durability is a very, you might think of it as like, okay, of course, Hussein, it's given that it has to be, if I write something, it has to be there. But no, some databases write to memory first for a performance reason, and if the container or the host dies, they forget to flash to disk, you just lost your stuff. But guys, what do you think about this, guys? Thank you so much for watching. Have fun, enjoy the rest of the course, and I'm gonna see you on the next one. Goodbye.